Hi, this is Noah. In this video, I want to talk to you guys about widening a bridge out. In this video, it's going to be specifically for 90 footers. At least the models I have, I'm going to depict here are 90 footers, but the same thing is going to apply to other bridge lengths as well. So it looks like recently we've been getting a lot of calls for extending our bridges out. So these 90 footers come in 90 foot. I'm sorry, they're 89 foot long. They come in 9 foot wide. Let me pull some measurements on here for you real quick. So I have two of our kind of common models that we have. There's other videos that talk about this, but this is a flush deck, and this is called the raised side sill. Um, the side piece here, this little Z channel thing, is called a side sill. You can see the side sill's flush with the deck, and this side sill is above the deck. Okay, and they're both the same height. Let me grab a measuring tape real quick. So if we measure from here to here, you can see it's about 13 inches or so. If we do the same thing here to here, right, it's about 1 foot 5 inches. All right, so there's not a huge difference in the height of those, but obviously one sticks up higher than the other. Okay, so I'm going to focus on just the flush deck, because if you're wanting like a 12 foot wide, then we want the flush deck, and these are going to be 9 foot, right about 9 foot. You can see that's 9 foot. When we go to these, the overall width of these is 9 foot. Well, 9 foot 9 3/16, and inside is usually about 8.6. Let's see what this one is real quick. 8.6 1/2. Okay, so that's usually when we're going to widen them out, we use the flush decks. We can use these as well. I'll talk about that in here in a little bit. But what does that look like? And some people want us to ship the 9 foot deck out and then ship like a kit, like a pre-cut pieces that we send to a job, and you can just apply them to when we're at the job site. And we do that whenever we have a crew out and we're going to install the bridge ourselves. We'll cut it ourselves. We'll send the steel already pre-cut on our pickup truck or our delivery trucks, and we'll do it ourselves. But for most clients, if we're just selling you the bridge, what we're trying to encourage clients to do is do the widening yourself and save time and money. Instead of having our crews drive all over the country, hire your own local welders and have them do this. And there's been several times where I'll fly over the country and I'll consult with your own guys, with your own contractors. I'll check up on them once or twice a week. If they get stuck, they can call me, or if they never get stuck, they don't need to call me. So we are here to help if your contractors or your welders get stuck. But what does it look like? What does it look like to widen this thing out? And you can see that's what this is right here. That this is all it is, right? It's just a whole bunch of C channels. Okay, and these are going to be about 1 foot 5 inches long. Let me pull some measurements for you real quick. Now, the actual size of this is going to vary depending on your application. So I'm just giving you some kind of general numbers. Okay, but I'm using a C10. Let's see what I have here, what I have drawn out. This is going to be a C10. Why isn't my window coming up? Let me pause the video for a second. Okay, we should be back now. All right. So this green arm, if I open this bundle up, that's a C10 by 15.3. That's a very common size that we use to extend these things out. Is a C10 by 15.3. Obviously, for your weight, for your application, don't just assume that it's going to be that C10. But there's a whole bunch of C10s, and these are generally about every 3 foot or so, every 3 to 4 feet. We put these. I have them spaced here at 3 foot, but again, this is just like a rough rule of thumb. All right, and then this bigger piece over here, this is just another C channel. I used here a C12 by 25, meaning that's 25 pounds per linear foot. Okay, and then on top is just a 1/4 inch plate going the entire length. Now let me bring this rail car down so you can kind of see what that looks like. Bring it down. I believe that's going to be 60 feet is what I put that at. 60 feet. Okay. Now I'll go to this side. Okay, so that's all there is to it. So you just you start with just cutting these C channels to length, the green ones. So the process is, let me explode that for you real quick. So the first step, whenever you, let me take these apart real quick. I'm going to bump that out, let's say 48 inches, and I'll bump up the steel plate 48 inches as well, 48. Okay, so whenever the rail car gets there, the first thing you're going to want to do is just take these green C channels, the C10 by 15.3s, and weld them to the side of the bridge all the way down. Now, and it honestly, it sounds easier than what it actually is. These rail cars, these bridge decks, the side sail is never perfect. It has a little bend here, a little bow there, a little ding there. So widening this out, it's even though it looks really simple, even like you can see here, the side sail's kind of contoured out. We seldom ever make the bridge 12 foot wide all the way to the variant. If we did, we'd have to add some steel here to reinforce this, or to put some more metal where the side sails being where it was trimmed out at. And then it's just a matter of adding all these C channels. You just hang them on there and you tack them up, then you weld them on. Okay, once those are welded on there, all the way down, and hopefully when you do that, it's critical that this line here is pretty straight, because then your next step is going to be adding this piece here, right? Adding this C12. You just take the C12 and you 48 inches, you slap it on there, and then you weld it up as well. You start welding up right inside here all the way down. And once that's welded on there, you take this plate here and this is by far the easiest part, is just taking this plate and you put it right on top. Okay. The benefit of doing it on site versus us doing it is, the biggest one's going to be transportation. Shipping 9 foot, we're already over with. Typically, like 8.6 is legal load. So at 9 foot, we're already over with. The over with permits for 9 foot, anything under 10 foot wide, shipping on the highways, typically not a big deal. It adds a couple $100 to the delivery fee. But 10 foot's pretty simple. Once we get to 12 feet, that's when it starts getting pretty expensive. 12 and over, if we can do like 10 foot 11 inches, that would be a lot better than exactly 12 feet. 12 feet can be just really expensive. That's police escorts in certain states. It starts getting pretty expensive. And the other concern is the durability of this. So the actual rail car itself, the original bridge deck, man, these things are super solid, super thick, super awesome. I've drugged these things, I dropped them, flipped them. I've done everything with these, and they're super solid, super stout. But any of this new stuff is not so stout. So if you're having to drag it into place, or you're having to move bridges around, maybe a temporary use, this is just not very sturdy. It tends to get damaged on these corners here. So that's also important consideration. The other thing is the weight of the bridge. So this bridge itself, whether it's this one or the raised side sill, they weigh about 42,000 pounds when they arrive to you, just the way they are, with all the parts removed. How much weight is this other stuff going to add? I actually did some math for you here. Starting with the C10s, we have 1.5 linear feet of C10s. So that's 22.9 pounds per piece, and there's a total of 62 pieces. So that's going to add about 1,400 pounds to your bridge. And then this 90 foot of C10 by 25, it's going to add, each length is 2,200 pounds times 2. We're adding 4,500 pounds. Just for nomenclature sense, you heard me say that this is called a side sill. We call this the secondary side sill. And these crossmember, the green pieces, if you want to sound like a bridge guy, if you look at the rail car, you have these longitudinal crossmembers and transverse crossmembers. So these are the secondary transverse crossmembers. The primary transverse crossmembers are here, and now we're adding some secondary transverse crossmembers, and then we have some diagonal crossmembers down below here. Okay, so So we're adding about 4,500 pounds because of that side sill, secondary side sill, 1,400 pounds to this secondary transverse cross member, and then the plate on top. We're adding, boy, that's pretty light, 250 pounds or so. For quarter-inch plate, and sometimes we have to go a little bit thicker, but quarter-inch is a pretty safe number to use. That's 10.2 pounds per square foot. Here's the math. So I come up with about 250 pounds per square foot or so. So that's how much. And this is for that 252. That's for the entire bridge, both sides. 1423. That's for both sides as well. So so we're adding over 5,000 pounds. So now instead of 42,000, we're at 47,000. Maybe 48,000 pounds. We're starting to push, 50,000 pounds. So your crane's going to be much, much larger as well. And getting this bridge navigated into the backwoods, into the delivery site, can be also problematic. So I do like the idea of if you can do all this on site instead of having us ship it. In some areas we don't. If you're more than 500 miles away from our shop, then we're probably not even going to offer this kind of package, the 12-foot wide package. We'll offer you the bridge deck, and I'll always suggest that you instead of widening this out, I'll suggest that you put two of these rail cars side by side instead of doing all this widening out, because it's just going to be a lot stronger of a bridge. It's going to be a lot wider, a lot cleaner looking than doing all this extra work and just fine tuning this. Imagine the side sill here is not perfect. And so you're adding this C channel here, this green piece, and if the orange piece isn't lining up perfectly with the green piece, that's a lot of welding. It's a lot of labor to try to make it work. And there are things we can do with fillers and bars and shims, but it's just a lot of labor. So I really like the idea of using two instead of one. A couple other considerations whenever you are widening them out is the kickers. Diagonal cross members, these pieces right here. This particular rail car that I have shown has kickers on every single cross member. Whenever we have weight way at the far end of this side, transferring that weight back over here to the center sill, because that's what we're trying to do. We're trying to transfer the weight all back over the center sill. That puts a lot of stress on this angle right here. So oftentimes we will need to stiffen up this cross member, this diagonal as well. Now this is what I've drawn is typically what we would do for vehicular traffic. Now if you're talking about pedestrian traffic, then it's a whole different ball game. Pedestrian traffic would actually use the other rail car. Let me see if I can draw that real quick. Hold on a second. Okay, I went ahead and took that other rail car, and the race side sill one. I didn't want to spend a whole bunch of time trying to get this thing exactly perfect, and you can see these are kind of sticking out. They wouldn't be like that. Like now it's going to drive me nuts. So I guess I better do that real quick. Hold on a second. Sorry, I just looked at the time. I actually have a meeting to jump into here in a few minutes, so I got to wrap up this video. I got to be quick. So imagine this. Just imagine those seat channels aren't actually protruding into the deck. Actually, I guess I can just wind this out. Oh man, sorry about this. All right, that's as best I can do in the limited time I have. Okay, so that's the overall width is actually a little bit larger than 12 foot, but you won't know that. Okay, so this is what it kind of looks like whenever we're extending this out on a 90-footer with raised side sills. And we typically would do this if this is just going to be a pedestrian lane. So now when a car drives on this, these curbs act as, these side sills act as a curb, preventing that tire from hopping up on top. The benefit of this, if this is just going to be for pedestrian traffic, then we can really, we can delete this, we can delete this whole side sill over here. We don't even need this over here. We can delete that and just leave it open like that. And then these can be a lot smaller. Instead of a C10, we can maybe even do like a C6 or something like that. So doing it for pedestrian use is a lot easier to do. But for the most part, widths are controlled by almost all over the country. Widths are being controlled by the fire department. So in years past, we could make this work where the overall width of the bridge was over 12 feet or 12 feet, and then the driving lane was closer to 9 feet, maybe even 10 feet. But we don't see that. We don't see fire departments approving that much anymore. Now they're wanting 12-foot clear which requires us to do this over here. Okay. Um, Now the other thing is, well, how about guardrails? How about adding some support? Because right now that you have no support, you have no safety features. So if we wanted to add guardrails, it would have to be on the outside of this, mounted to this secondary C-channel side sail over here. And then we have to worry about transferring that weight once it's typically either a 6x6 post or a W6 by like a 16 I-beam. Now we have to worry how are we transferring that weight from that post when a car hits it back over to the center sill, and that starts becoming a lot more problematic as well. If this is just a pedestrian handrail, that's no big deal. Typically they're 2x2 posts that get mounted directly to the top of that. We don't increase the width. So pedestrian handrails are pretty easy to install. But if this is a vehicular bridge, then you should have vehicular rated guardrails, not pedestrian rated guardrails. Okay, so of course, if we're going to do it at our shop, that adds more width. It adds about another 6 inches on that side, 6 inches on this side. So instead of a 12-foot wide bridge, now you're looking at a 13-foot wide bridge, and then that's anything over 12 feet is very problematic to ship long distances. So you got to consider doing this, just building this on site for whatever reason. If you don't want to do two of them, and so the cost of a second deck is about equal, maybe even less expensive than doing all this welding, all this cutting, all this welding. Keep in mind that typically when we're doing this on site, this is over a waterway, so you have guys hanging over the waterway welding on this, and you have inclement weather, you have rain, you have cleanup time, you have setup time every single morning. So doing all this extra welding can be pretty expensive, especially since these side sails are not perfect, and we have to do a little bit of fab work, a little bit of fine tuning to make that work. And then setting this secondary side sail, that requires another piece of equipment, because this is pretty heavy. It's 4,500 pounds, so about 2,200 pounds. Over that's 1 ton. 1 ton you're having to hang off the side and set in place. That can get pricey as well. So I strongly encourage, if possible, putting 2 rail cars side by side. But if it's not feasible, then adding all the steel, right? And it doesn't make any sense for us to deliver this for clients. There's not a lot to it. We can call a local steel yard. We're in California, but if you're in Idaho somewhere, you could just call your local steel yard up and have them cut this material down to size for you, and not have us mark it up and be the middleman. Just order the steel directly from the steel manufacturer, have it delivered to your site, and then your welder. The welders typically are pretty smart guys. Once they have some direction, once they know that if they get stuck, I can go out there and give them a hand, or they can call me, and I'll be able to walk them through overcoming any obstacle. I've been doing this for almost 20 years. There's very few problems I haven't seen. So that's what I suggest. If we really need 12-foot wide, this is what's entailed. There's only essentially 3 pieces to do here. Oh, let me see this. Oh, look at this this other rail car. See how this for diagonal kickers, these diagonal cross members. This particular rail car only has every other one with the diagonal supports. So this one, if we're widening it out, we would need to certainly add some more of these. But even on this one here, we would need to add some more steel. We would need to reinforce this. Sometimes it's just as simple as adding some, like a 1/2 inch by 3 inch flat bar and welding it directly to the bottom of there. Sometimes it's more, depending. It really depends on the rail car and the application and the span. So there's a lot of variables. Okay, so hopefully that helps. If there's any questions at all, give me a call. I'll be happy to help you guys. All this steel that we use they're really off-the-shelf steel that you can find anywhere. C10s and C12s. We don't call out for any kind of specialty, goofy, WTs or anything like that. These are all readily available, so it'll make your job installing these pretty simple. But it is labor intensive. It is very labor intensive. Not a lot of pieces of steel, but they're heavy, and you're working off the side of a bridge, and there's a lot of fine tuning involved with doing that. Okay, but if you need to, that's how you do it. I don't think I have any other insights I can offer you. This exact same process we do for the 60s, 65s, 55-foot long rail cars. All the different lengths of rail cars. It's about the same process. Extra C channels coming out. We got this one on the very end, and then the plate steel on top. Okay. That's it. Hope you enjoyed this video. If you do, hey, do me a favor and just give me a little thumbs up on the video. Let me know who's actually watching this, and if I'm giving you any value. If you're learning anything, I'd appreciate it. Let me know. I appreciate it. Thank you. Bye.